Okay, in this video we're going to talk about solving radical inequalities. Inequalities become a little bit different because when we have even radicals, they can't be less than 0, so we have to put a lower bound on some of the less thans. So it's the same process, but we have to look at a few different things when we're solving the inequalities. So our first example is 3 square root of x minus 4 is less than or equal to 8. So when we're looking at a less than, we have to realize that there's going to be a number that x is not allowed to be less than. When we look at our radical x, we're looking really at our domain. What is x allowed to be? Well, x cannot be less than 0, so x must be greater than or equal to 0. This is our domain, and we're going to use that in the answer at the end. And we'll talk about different ones. If the square root of x minus 2, then if I take x minus 2 has to be greater than or equal to 0, we add 2, and x is greater than or equal to 2. That's going to be our lower bound if it was a less than equation, the inequality. So we find what the denominator must be greater than or equal to, and then we add that to our answer in the end. So in this first example, we're going to add 4 to both sides, and we get 3 square root of x less than or equal to 12, divide by 3, and the square root of x is less than or equal to 4, and then we will square both sides, and we get that x is less than or equal to 16. But we know that x must also be greater than or equal to 0, so and x is greater than or equal to 0 from our domain over here. And to write that as a single sentence, 0 is less than or equal to x is less than or equal to 16, and that becomes our final answer. Okay, let's look at another example. 4 times the cube root of x plus 1 less than 8. So we talked yesterday about graphing the square root and the cube root functions, and remember our square root functions looked like that. They started at a single point. They didn't have all real numbers as their domain, and the cube root functions did. So the cube root function was all real numbers, so we don't have to worry about the domain restrictions on solving these equations because the cube root's allowed to be negative. So when I solve this, I can just divide by 4. I have the cube root of x plus 1 less than 2. Cube both sides to get rid of the cube root. And then I get x plus 1 less than 8 minus 1. X is less than 7. And if I put it in, 7 plus 1 is 8. The cube root of 8 is 2. 2 times 4 is 8. So let me just show that. 4 cube root of 8 less than 8. 4 times 2 less than 8. So 8 is what makes it equal, so anything less than the 7, or 7 is what makes it equal, so anything less than 7 is going to be your solutions. Okay, let's do another one with a slightly different domain restriction. The 3 times the square root of x minus 1 is less than or equal to 12. So let's look at what the domain restriction would be. The square root of x minus 1. We're going to look at just that part. X minus 1 has to be greater than or equal to 0. Otherwise, it's undefined. Well, it's no real solution or imaginary. So we have to add 1. So x has to be greater than or equal to 1. So we're going to remember that for our answer in the end because we're looking at a less than function. So now I can divide by 3. The square root of x minus 1 less than or equal to 4. Square both sides. and I get x minus 1 less than or equal to 16. Add 1, x is less than or equal to 17. And it has to be greater than or equal to 1, so we write that as a single statement, 1 less than or equal to x less than or equal to 17. And that's my final answer. Do example of a greater than problem, and then that'll be it. So how about the square root of 5x plus 1 is greater than or equal to 6. So when will the square root be greater than a positive? Always. I don't have to worry about being less than a 0 unless I get a negative in here. So let's look and see what happens. Square both sides to get to undo the square. I get 5x plus 1 is greater than or equal to 36 minus 1. 5x is greater than or equal to 35. Divide by 5. X is greater than or equal to 7. And when I plug that in, the radical stays positive. It can keep going on forever, so I don't have to worry about any kind of domain restrictions when it's greater than. As